Hey, I just wanted to have a little bit of a video to introduce some concepts related to the chain rule. I noticed that a number of students in class are struggling with using the chain rule for exponentials and logarithms, so I wanted to do a quick recap and give you this resource to help. The basic idea of the chain rule says if you know how to find the derivative of a function, then if you have some expression going into that function, and we'll call that expression u, then we can find the derivative of the function of the expression, where you use your derivative function evaluated at the original expression as long as you multiply by the derivative of the expression. Now last semester you would have used this to be able to do derivatives, and all you really dealt with were powers. So for example, if my function f of x happened to be x to the sixth power, then you learned that the derivative of x to the sixth power is 6x to the fifth. And this is what we call the derivative function. So now that I have my derivative function, the chain rule allows me to take derivatives of things a little more complicated, like I could put a quadratic inside of the sixth power. And so here what I've got is my expression that goes in the function is x squared plus 2x. And so I'm taking a derivative of f of u. So when I take my derivative, it's going to be f prime of u times du dx, where my f prime is the 6 u to the fifth power times the derivative. And what I'll do is I'll take this formula for the expression x squared plus 2x, and that's what goes inside the u, and I'll find its derivative. The derivative of that expression is 2x plus 2, and that's what gets to go in place of my derivative. So when I use this expression, what I find is that my derivative is equal to 6 times x squared plus 2x to the fifth power, and then I multiply it by 2x plus 2, the derivative of the expression. This is the chain rule. Here's my f prime of u, du dx. Now when it comes to problems with the exponentials, our basic function is my function f of x is the natural exponential function, because the derivative function of that is itself. And so what this tells me is that when I take a derivative of e to the u, it's the derivative function. This is f of x. Sorry, f of u. Let's fix that. F of u. I'm going to get the value f prime of u. In this special case, it is itself, but the chain rule says you have to multiply by the derivative. So for example, if I needed to take a derivative of e to the x squared, in this case my u is the expression x squared, I get e to the u, which is e to the x squared, times the derivative of u, which is 2x. And we'd normally write this 2x e to the x squared. Similarly, if I have logarithms, if my original function were the natural logarithm function, we know its derivative function is 1 over x. And so if I want to take a derivative of the natural log of some formula, like 3x plus 5, my u is the expression 3x plus 5. And I get the value f prime of u, which is 1 over 3x plus 5. This is my f prime of u, times the derivative of u, which is 3. And so this is how the basic idea of my calculations using the chain rule are going to work. Now let's look at a little more complicated example. I want to consider this example of a function that is e to the 2x plus 1 in parentheses raised to the 4th power. And if I think about what this is doing, I'm taking the expression u equals e to the 2x plus 1, and it's getting put into the 4th power function. So my basic function that I'm working with is y equals u to the 4th power. So if I have y equals u to the 4th and u equals e to the 2x plus 1, another way to think of the chain rule is to say if I want to take a derivative of y with respect to x, it's the derivative you would get if you took a derivative with respect to u multiplied by du dx. And so I can do these parts. Y prime is maybe dangerous because I don't know if I'm talking about dy du or dy dx. dy du equals 4u cubed, and du dx, the derivative of the expression, well, it's the derivative of e to the 2x plus the derivative of 1. And the derivative of 1 is 1, or 0, sorry. Derivative of 1, it's a constant. The derivative is 0. So, sorry, that should have been drawing. This is the derivative of e to the 2x. Well, that's an exponential. And the derivative of an exponential is e to the same power times the derivative of what was in the exponent. So I get 2e to the 2x. So when I combine these pieces, my derivative f prime of x is going to be 4u cubed, so it's 4e to the 2x plus 1, plus 1 is not part of the exponent, to the 3rd power, times 2e to the 2x. And I really should combine the terms that I can, so the 4 and the 2, those are shared, and so I get a value of 8. Let's put the exponential by itself, e to the 2x, times e to the 2x plus 1 to the 3rd power. And so this is the formula for the derivative that we were looking at. In a similar way, if I had a function, let's do one like this, the natural logarithm to the 5th power of x squared plus, well, we could do the same thing, x squared plus 1, then this power, 5, is actually saying I take x squared plus 1, compute its logarithm, and then raise the result to the 5th power. We usually want to think of that maybe by rewriting it with parentheses. Take the logarithm of x squared plus 1, take that quantity, and raise it to the 5th power. And so what I recognize is the last thing that I'm doing is I'm finding a 5th power. And so I ask myself, what is it that's to the 5th power? That doesn't look very good. U to the 5th power, where u equals the natural log of x squared plus 1. And this happens to be a function of something else. It's the natural logarithm, maybe we could call it w, where w equals x squared plus 1. So that when I calculate the derivative f prime of x, it's going to be 5u to the 4th times du dw times dw dx. This is the chain rule being applied twice because the chain has 2 levels of depth. So it's 5. Now what's being raised to the power? it was the logarithm of x squared plus 1. And it's being raised to the fourth power now. And the derivative of the logarithm is 1 over w. So that's 1 over x squared plus 1 times the derivative of w gives me a final factor of 2x. If I combine some of those terms, don't know if I can fit this. Let's see, what can I do? 5 times 2x is 10x over x squared plus 1. I get the logarithm, that's now the fourth power of x squared plus 1, and sorry, it didn't quite fit, but it's close. This is the basic idea of how the chain rule allows us to do our calculations.